Section 2.5, 2.6, Combinations. Combination is arranging all or part of a set of distinguishable objects where order does not matter. In a previous section, we talked about permutations. Permutations is arranging all or part of a set of distinguishable objects where order does matter. So now, how are they different? Think about students choose two letters from the list A, B, C. The possible number of arrangements, we can have AB, BA, AC, CA, BC, CB. There are 6 different arrangements to arrange 2 of 3 letters A, B, C. Just to verify, using our permutation formula, we have n factorial divided by n minus r factorial, where n is 3 and r is 2. So we have 3 factorial divided by 3 minus 2, 1 factorial. 3 factorial, 3 times 2 times 1, gives us 6 different arrangements. Taking a closer look of our 6 possibilities, we can see that AB is very similar to BA. When order is important, they are 2 different arrangements. However, if we are just talking about a combination of letters, AB and BA would be the same combination of letters when order is not important. Similarly, AC and CA would be the same combination of 2 letters, and BC is the same as CB. So instead of 6 different permutations of 2 letters, we now have each group of 2 permutations is just 1 combination of letters. So a number of combinations can be given by a formula. In general, given a set of n objects taken r at a time, the number of possible combinations is given as a formula similar to a permutation formula. Instead of permutation, or P, we have C, combination. So the combination formula is n factorial divided by r factorial, n minus r factorial. Or we can consider that combination as related to the number of permutations, but we divide by the number of ways to arrange r factorial letters. Those are the ways where those combinations, the order does not matter. So specifically looking at the example above, if we have a combination, we have 3 letters, and we are choosing 2 letters at a time. If we use that formula, we have n, where n is 3 factorial, divided by r would be 2 factorial, times n minus r. And that would give us 3 factorial over 2 factorial times 1 factorial, 3 factorial, 3 times 2 times 1, divided by 2 times 1, and that will give us 3 combinations. We can also see that 3 combination 2, or 3C2, we can think in terms of the permutation formula. So when we looked at the permutation earlier, we noticed there were 6 possible permutations where order matters. If we divide that by the number of ways within each 2 group, the number of ways to arrange 2 letters in each group, there are 2 possible ways. So we are going to divide this by 2, and that gives us 3 different combinations of letters where order is not important. So again, we have two formulas. These will be given. And one extra piece of information is a combination may be written as NCR, but another way to write or denote a combination is in brackets N choose R. So in the example above, we would write that as there are 3 letters and we are choosing any 2 letters. We would say 3 choose 2.